We'll be on Twitch, but whatever. Maybe. I don't know. Hello.
Yeah, are we live?
Dude, we should be. It takes like 30 seconds or so. Dude,
Let's
see?
check it out.
Dude, there we are. We're live.
Oh,
Dude, turn up that volume.
cool.
Cool. Why aren't we live on Twitch, dude?
I don't know.
Dude, refresh that page.
Dude, I will. Dude,
Oh, dude.
There we go.
Welcome, everybody. Because we got all them viewers out there watching.
Heck yeah. Hello.
Hello.
If you notice, Kip and I are on the same screen tonight.
That's pretty cool.
Why is that, Kip?
Dude, because I'm in Flagstaff. Because I just bought a bus and driving it back. So
Nice.
me and Jaden decided to do this together tonight.
Yeah, so we're just making it work. We're having fun.
Yeah.
Dude, we can touch each other. It's not in bad ways, but it's good.
Yeah, it is good, dude. If anyone out there is watching us right now,
Yeah, will you let us know?
will you let us know? What the?
What the? Okay.
Okay, so we got one. We got one person. That's good.
Sweet. Well, one's enough.
Yeah, dude, one is enough.
Why are you in the same thing? They must have missed our explanation. Hey, Kip.
Dude.
Why
What?
are we in the same shop?
Well, because I picked up a bus from Phoenix today. Jaden lives in an undisclosed location between Phoenix and the place that I live.
Flagstaff.
And so I, stopped here on our way home.
Right.
And we're doing it together.
Sweet.
Sweet.
So hopefully everyone got that now, and maybe we won't get that same question over again. But if we do, dude, maybe we can do the same thing again.
Dude, maybe.
Okay, well, Kip, last time we talked about light spectrum, right?
Maps bus. Yeah.
The maths bus, yeah.
Yeah, so last time we talked about the light spectrum.
Uh-huh.
And so...
Angie.
Yeah, so tonight we're going to talk about the next part. And up to this point, we've been following Light's backstory.
Right.
But now we're actually going to start Light's journey through the camera. And the skill he's going to learn tonight is going to be very, very important to helping Light make its way all the way through the camera.
And what skill is that, Kip?
Dude, that skill is called refraction.
Cool, I hope everyone can read that. It's on the screen.
Yeah.
Cool, let's dive into it.
Dude, should we dive
But
into it?
before that, I think we need to sell ourselves and talk about
I agree.
donations.
Donations.
So, we talked about this last time, and we want to talk about it again. Stickers. These are really cool. Art by Shaylee. Is that her tag on here?
I think so, dude.
But Shaylee, if you know her. She's really awesome. Donate $5. We'll send you your choice of a sticker, either the Light Man or the Dungeon Camera. And if you donate up to $25, you'll get this cool t-shirt of Light going into the dungeon, which is the camera, and this cool little studio background. And you'll also receive the sticker at the same time.
Yeah.
Right?
Cool. That's exactly right. And for all you guys out there to figure out how to do this on Twitch, you just click on the button that says donate. On YouTube, it can be a little more complicated if you're watching on the phone, because to find the description, you actually got to click the X on the live chat, and then there's like this little tiny arrow thing that you got to click on to show the description.
Okay.
And that's where the link is on YouTube. I'm not sure how it works, like if you're looking at it on your browser, but that's how it is on a phone. So yeah, if you want to donate, that's how you do it. And also, along with that, if you don't feel like you can donate $5, again, we are willing to wrap your name that shows up above there, right over there, where Jaden, where over there somewhere.
Over there,
yeah. In one of these beautiful textures. This will probably be the last week of these textures, because we'll probably be done with anything to do with rainbows by next week.
Yeah.
So if you want to donate, now you know how.
Sweet.
Should we get into it then?
Yeah. And we need a little bit of a review.
We
just
do.
Talk about what Light has at this point, right? What are his skills so far? And that is the visible light, right? We talked about that. The Roy G. Biv. So red to violet.
Yeah.
The rainbow colors. We know the wavelength is from 400 nanometers to 700 nanometers. That is what our eyes can see. We talked about other animals might be in some of the infrared or the ultraviolet, but for humans, that's where we are at. And also the frequency, 430 terahertz to 790 terahertz. And we figured out that the power level, it was right in the middle of all the power levels, right? We're pretty strong, not as weak as some, not as strong as some. Okay, and then we have these kind of confusing equations. But the most important thing to remember about those is that third equation, the C equals frequency times the wavelength.
Yeah.
And that is the important part for this review.
Exactly. And that C is the speed of light. Okay, so it's the speed of light equals the frequency times the wavelength. But later on, we're going to talk about this, and it's not just the speed of light, but it's just the velocity. So it doesn't necessarily need to be the speed of light. And we'll see how that kind of, plays a role in what we're going to go over tonight.
That's awesome.
Yeah, dude. Pretty awesome.
Okay.
And that leads us to our first thought-provoking question.
Why is the sky blue? Yeah, so let's hear everybody's thoughts about this. Write in the comments. Kip and I will be waiting for some answers, and we'll be talking about cool things probably, because we are cool, and you guys should probably be talking in the chat right now.
Yeah, probably.
While I'm talking this gibberish. What do you think, Kip?
Yeah. Dude, apparently we look cute together.
We do?
Yeah.
Dude, you guys are... Thank you.
Thanks. We appreciate that. Should we always do it together? Should I just move to Flagstaff?
Probably.
Dude, you think?
Yeah.
Okay. I mean, the undisclosed location?
Yeah.
Yeah.
Right. So, we're waiting to hear, why is the sky blue? Because it is sad. Okay, that's an answer.
That's an answer. That's good. Anyone else out there got any thought-provoking? Or what? Any answers to our thought?
Yeah, any answers to the thought-provoking question?
Oh, because, yeah, okay, so that just barely popped up because it's sad. Huh. No one cares why the sky's blue, I guess, tonight.
Because it didn't get invited to Jaden's birthday party. Well, lucky for the sky, I did not have a birthday this year. And I won't for the rest of the year either.
You won't, dude?
No.
Dude, why is that?
Don't
tell him. Don't tell him.
I'm not going to tell him.
Don't tell him. It's a secret.
You got to figure it out yourselves. Okay, Kev, I think we give him... The air is blue in its core air particles. I'm not sure what that means. The atmosphere refracts the blue part of the spectrum and keeps some of that blue light up there. Okay, I'm liking these answers now.
That's good. I like
that's
that.
Good. Do we want to go ahead and...
Sure, let's go for
it. Okay, so the answer is because of scattering. And what the heck is scattering? So light enters our atmosphere, and I kind of like that the refracts apart, right, with all the particles in the sky. I like that answer. Wait, we're getting more.
Yeah.
Because of space. Thus, as sunlight of all colors passes through air, the The blue part causes charged particles to oscillate faster than does the red part. More of the sunlight enters the atmosphere is blue than violet, however, and our eyes somewhat more sensitive to blue light than to violet light, so the sky appears blue. Cool.
I feel like that was a copy and paste.
Yeah, that might have been copy paste. But yeah, the simple answer, right, is the light enters the atmosphere, and light starts bouncing between particles in the atmosphere, gases, dust, all that. And the wavelength of blue light is shorter, so it bends more than the red part of the spectrum, and that is why we see more blue in the daytime than the other colors of the rainbow. If you've noticed, sunsets, they are more of the orange reddish color. And
Yeah.
why is that, Kip?
Well, that's because, so if you look at the Earth, right, and you look at the sun's kind of like at a weird angle at it now, right?
Right.
And so those blue particles, they're not actually, they're bending kind of essentially too much
Right.
of sorts. And so you're left with, I agree. It was a copy and paste. And so you actually get this, the red is the only thing that's bent the right
So
amount.
it's like bending. Right. Okay.
Yeah.
And that's where we get the red.
We'll get into this a little more in a bit here.
Right.
But this is good, just to start it all off. So now we know where the sky is blue during the day
Right.
and red at night.
Scattering. That's what you guys can just tell people.
Scattering.
Oh. So we got a level up here, Kip. So light is now level 3, and the new ability is refraction. So
Nice.
during this day, we are going to talk about refraction and what cool things light can do with refraction. And that is the goal for today, is to just share how cool light is and refraction is. So level up, woohoo!
Cool. So let's talk about it, dude. So now that we've leveled up, let's learn what our new skill is. Okay?
Deduct points for cheating. Okay. Yes, Kip. What were you saying?
So the first thing is, dude, is that when light is refracted, what that means is, let's say, so light's normally traveling through space, okay?
Right.
In the sense of the Earth hitting our atmosphere, now it's getting hit by air, okay?
Okay.
So it was in space with nothing there, and now it's hitting air.
Okay.
And from that, it's actually going to change the speed of that light traveling, right? So
Okay.
it's going to change speed. It can slow down or speed up depending on which medium. We call these different substances that it goes through.
So
a
if
medium.
light leaves the atmosphere, then it will speed up.
Right.
Light enters our atmosphere, it slows down.
Exactly.
Okay.
So it essentially, when it hits this medium, it has to interact with it, right? But light's kind of weird. So it doesn't have mass, right? It's just it's this electromagnetic wave.
Right.
So how does it interact with another substance? Well, like Angie's last answer, talking about this idea of electrons, right? So this electromagnetic wave has an electric field associated with it, right?
Okay.
And so that electric field will actually affect the electrons in the atoms, because everything in the universe that we know of thus far is made up of atoms, right?
Right.
And those atoms, part of those atoms are the electrons, and those electrons sit there, and when they get hit by an electric field, they sit there and go brrr.
They get energetic, right?
Yeah.
They get some energy of light.
Yeah, exactly. Okay. And then because of that, it actually, that's creating a new electromagnetic wave, right? A new light wave.
Right.
And because of that, we actually get like this weird sort of new wave. So you add the two waves together and you get this new wave, and through that process, your wave actually slows down or speeds up depending on the material.
Okay.
Um,
So you all ever noticed when you're swimming or anything like that, when light enters or when objects enter, it kind of shifts a little bit or bends a little bit. Lucky for you all, if you have never seen that, we have a little experiment for you.
Yeah.
Should I grab it?
Dude, grab it. And all you at home, if you want to, grab a glass of water.
All you need is a glass of water.
That's see-through. And put some water in it, and then put something hard.
You see this?
Like a stick or a straw that goes in it.
Ah, it's bent. You see that?
Yeah, dude. How'd you do that?
Dude, I just put a straw in water in a glass cup.
Dude, and you bent it?
I bent it.
Dude, the straw's bent?
Yeah,
dude, let me
see.
Dude, let me pull it out of there. Dude, because it's looking bent, right?
Right.
So, whoa, dude, but now it's straight.
Dude, how'd you do that?
Dude, I don't know. You bent it.
So, this is what we're talking about, right? When the light reflects off the straw, our eyes interpret it, and it looks straight when it's out of the water. But when it goes through the water, light slows down because this medium is a little bit denser, a little bit thicker than the air, right? So we have more particles, more things to interact with, so it slows down.
Yeah. And so with that, like, what happens as well, because it changes, right? Like, how does it actually end up bending? Well, the idea is that the electric field on both sides of this water actually has to be the same.
We have a good question. Why do the colors look so much warmer and prettier during the golden hour? We kind of talked about this during our scattering slide, or why the sky is blue sky. Yeah. You want to say?
Yeah, so the reason why, and we'll get into this a little more when we talk about rainbows, but the reason why is that based on the angle of the sun compared to the earth in that moment, well, where we're standing on the earth, the red light is bent more into the earth than, say, the blue lights or the purple. Right. And so you get left with like the yellow, oranges, and reds, and that's kind of all that's left at that point.
It's like the red's bending to you, and the blue and stuff is missing your point.
Yeah.
Right?
Yeah. So we'll go over this. It'll start to make a little more sense, and we'll probably recover that. But great question.
Yeah. Kippa's gotten amazing with animation, if that's CGI.
The cup and the bent.
Oh, yeah.
Anyways, but the reason why it gets bent is because if you remember, we had a video about vectors a long time ago.
We did.
And the idea being that this vector kind of gets bent and changed, and there's all sorts of really complicated math that me and Jaden spent a lot of time learning about, but it's just kind of too much to
You don't need to know that to know the concept.
Yeah, which is that it bends. And if you want to learn more, you can shoot us a message and maybe we'll send you a video that explains it more in depth, why it actually bends.
Right.
That being said, let's move on to Snell's Law.
Dude, Snail's Law? Or is it Snell's Law?
Dude, it's...
I don't know.
know.
So, oftentimes this law is called the Law of Refraction. It basically tells us if you have two different mediums and you're sending light through it, this equation can tell us the angle of refraction compared to the normal, right? And the normal is our little dotted line down the center of our little graph. And yeah, that's what this equation tells us, and it's very useful in this situation.
Yeah. So like that, what the normal means is it just means that it's at a 90-degree angle perpendicular, or all the fancy words for it.
Orthogonal.
Orthogonal to the surface of the object, right? So if we picture on here that line is like...
I should jump to the top. Yes.
Yes, except for the fact that we already answered it and you weren't here, so you should maybe get deducted for that.
You're a little tardy.
Yeah. Good thing this is an actual school.
Yeah.
Slow law. Yeah.
Yes.
So anyways, we can picture that black line. Let's say that that's like a cup, right? And so the light is going to hit that cup and then it's going to bend. And you can actually calculate how much it's going to bend. And it's based on this idea of this n. So what that n represents is it's like how much the speed of the light changes, right? So n equals the speed of light divided by its new speed. And so you can kind of just like, there's charts and tables out there that will tell you what the n value is, but it's
right. There's different indexes for like air, water, glass. People have already calculated these things, so you can just look them up.
Yeah. And so
Oh, our first challenge of the day. So, using that equation or educated guesses or just guesses, we want you to answer this question. What angle does it bend to? So we're talking about from the left-hand side, to the white square. That's what we're talking about, right? The theta 2. All right,
Yeah.
What angle do you think that is going to be?
And wrong 2. Oh, whoops. Yeah.
Oh.
Oh,
So,
well.
yeah, you can calculate this using that equation that we just had. You might be able to type it in Google. You might be able to just guess it. Maybe using an educated guess. I don't know. What other strategies could we tell them to use?
I don't know.
Maybe just solve it.
Yeah. Solve it. So if you remember, the equation is n1 sine theta 1 equals n2 sine theta 2. Right. And so,
we're given all the thetas and we're given the n's, so...
Yeah. So we're trying to find theta 2. We're given n1. We're given theta 1 and n2.
Right.
So...
the missing thing that we're solving for is theta 2. So go ahead, write your answers in the chat. This is our first challenge. We might lose health today. Who knows?
Yeah, we might. Especially if no one answers. That's automatic. Ooh, we got a B.
We got a B.
Okay.
90. Okay.
It doesn't look much like a 90, but go for it.
It's all right.
I mean, I don't know.
At least it's an answer.
It actually looks like I did a pretty good job on my guesstimates. I'm not gonna lie.
Yeah, I like it.
Um,
we got also a C.
Okay, a C.
But that was from same person.
Well, I guess they can change their answer because
I changed my mind. Okay.
Okay. Yeah.
So we got a C.
Cool. 1 C. Well, Jaden. I don't know. We got 1 C. That's all we got, dude.
I feel like there was like a lot of things going on.
Just
in
remember,
the chat, and then everybody
just like everyone stopped. We blew their mind with, maybe we sassed them too hard. I don't know. But just remember, guys, you get points for answering questions, even if it's wrong. So
right.
Or A, ha ha.
So you got to make up your mind.
Choose one of them. You can't have 3 answers.
E. We got an E. Okay. Cool. Should we call it there?
Yeah.
Wait. We'll wait for Kelsey. Kelsey, make up your mind. Which one do you want? A, C, or B?
The world may never know.
Right. I'll stick with C. Okay. Cool. Well, what is the answer, Kip?
Jaden, the answer is C.
C. Awesome. Okay, so the answer is C, 19.5.
So we got one right, one wrong. So we get one added to our deal, right?
Right. So we got to go to our dice roller.
Here's
Bad
our-
guy roll, and we're taking the minimum because lucky. Taking the minimum because it was a harder question. And then what's the good guys roll going to be? So remember 8. Lucky. And
it's 1 and 1, so
I don't know. We didn't make a rule for that. Should we take the 13 or the 2, chat? Yeah. We'll let you decide.
I mean, I'm tempted to take the 2 just because
we can get some red.
Yeah.
Okay.
Do it.
Let's just do
I don't even
red.
know if it'll show up because it's so far. So they get -5 health, dude.
Yep.
Did it even show up? Should we see? Oh, dude, it showed up.
Oh no.
So, also to go through it really quickly with you guys, what we did. So if we go back a slide, looking at this equation, we have n1 sine theta equals n2 sine theta 2. We want to solve for sine theta 2.
Right.
So we divide n1 sine theta 1 by n2.
Right.
And then we take the sine inverse of that
to get the angle.
To get the angle.
Nice.
Cool. So.
And for future, if you pull up Wolfram, you could probably just tell it to solve.
Yeah.
And it might do it.
You probably don't even need to type solve. It would just do it.
But oh!
Ah!
Our second challenge question. Back to back, Kip.
That's
You're trying to kill us.
Yeah, dude.
So what happens when light leaves? So that's talking about from the white square rectangle outside of it on the right hand side. So they wanted to take the 13.
Yeah, I know. Too late for that, dude.
Too late.
We're harsh tonight.
Yeah. So what would the angle be coming outside of the white rectangle?
Yeah.
Right?
Exactly.
So it's going in at the 19.5. What angle is it going to leave?
So it's that angle. Yeah, I don't have it marked, but what is it going to, when it leaves, what's the angle going to be?
So we have light going into a medium from, I guess we can call it its original.
Yeah.
And exiting that medium to back to its original. So that might be a helpful hint. I don't know. But we'll see. Give us the answers. Write in the chat. Where it going though? Back to the original medium.
Yeah, so it goes in to the thing, right? So it goes from air to this, we'll call it glass, and then it leaves the glass. So when it leaves the glass, what's it going to be? And this is kind of a trick question, not going to lie.
Okay, we got one answer, C.
Okay.
And also an I'm confused.
We'll see if we can clear it up. I don't know how to mark
So,
up, dude. Oh, wait, can I laser point, dude? Where's my laser pointer?
Oh, yeah, you probably can.
So we're talking right here.
What angle does that leave? Yep.
Yeah, right there.
It's showing up.
Ooh.
So is that going to be A, 30 degrees, B, 90 degrees, C, 19.5 degrees, D, 10 degrees, or E, 12.3476 degrees?
Yeah. The world may never know.
We maybe never know, or we might.
We might. Okay, so we got one C. Is that what we're getting?
Still got one C.
Dude, this was too complicated, I guess. People can't handle it. Should we roll the dice?
We can get any other answers, you think, or?
I don't know. Oh.
Oh, we got an A.
Ooh.
Okay, let's roll the dice now. So we got one A, one C. Did any of them get it right?
Yeah, dude.
Dude.
A.
A is the answer. So it comes in at that 30-degree angle, and when it leaves back to the same medium, it will be the same angle.
Yeah.
So that is
so the important
really
part
cool
to know about that, right, is that it will leave at the same angle, But if you notice, right, the trajectory of this light,
it's shifted
it's
upwards,
shifted.
right?
Yeah. So, or I guess in this case downwards, because right, it bent towards the
right.
normal. So if you were to go straight, if you were to keep following this line, right, it would have come up here.
Right.
But instead it's down here. So that gives that weird bent perspective that you get, right?
Right.
And so that's how that happens. And, you know, these angle, I guess we'll roll the dice first and see how.
Okay, yeah, let's roll it.
We do here, dude. Ready? Here we go. Is this a tough question or an easy question?
We'll say tough again.
Okay, so we got 16. And then this time we'll give it to, we'll give him the nicer side because it was 1 and 1 again.
Yeah.
And we got 10.
10 plus 1.
10 plus 1 is 11, so we got another -5, dude.
Nice. That's consistent.
Yeah, dude. Uh-oh.
Dude, we need people to get on here so we can have more right answers.
I know.
Oh, well.
Whatever. It's all good, dude.
All right. So this is our second thought-provoking question. Kip was just like startled for some reason. I don't know. It was just awesome. So what is a rainbow? And why is it round?
Start thinking away. There's a lot of questions in this one. It's all good.
Right. What is a rainbow? You can start with that. Then you can say, why is it round?
Yeah.
Or you can start with, why is it round? And then you can go back to the rainbow part. Yeah.
Yeah.
Rainbows are pretty cool.
For why is it round, you can think, what shape is the sun? You know?
Oh,
that might... or what makes a rainbow, right? Like, where does it come from?
Right.
Because of refraction? Okay, that's good, but why is it round? Because if you remember from our last slide, it just bent the light at a weird angle. It, like, when you look at the straw, right? It's not round. So...
yeah, it's just shifting it.
Yeah.
That is weird.
That is weird.
Dude, have you ever tried to find the end of the rainbow?
Dude, I've made it so many times.
Dude, are you rich?
Yeah, dude.
Got that pot of gold? Lucky.
Okay, we got light. Okay, so that's what a rainbow is. Good.
Cool.
But why is it different colors?
Yeah.
Why didn't it just bend, right? Like this, the straw is in different colors.
Yeah. Huh. And it's round because of the atmosphere.
Okay.
Okay.
So should we go for it, Jane?
Yeah.
All right. So here's the deal. Remember, Jaden.
That's why he bought the bus. Okay, yeah.
So we've got the color spectrum. Remember that? We go from red to blue, purple, violet.
Yeah. Ruby Jiv.
The thing is like you were talking about at the beginning, you know, those electrons vibrate differently based on these different frequencies.
Right.
Okay? So each one of those frequencies is actually going to refract a little differently. So that N value that we showed is normally for, like, I think yellow light, like the in between the spectrum.
Okay, so that's right in the middle.
Right in the middle.
Okay.
But because that N value is just for yellow, there's actually a different N value for every wavelength of light.
Okay.
And so in this case, right, if the N value for purple, let's see here, I gotta do the math in my head. Is it greater or less? It's
for
purple. I gotta think here.
It'd be more, right? Because it bends more.
Yeah, right. Yeah, I think you're right.
I
You're right. So for purple, it's actually going to bend more, so the N value is higher. Right. And for red,
because it would slow down the most.
Yeah.
Yeah. Okay. Got it.
For red, it's going to be less, right? So if we go back to that last slide here, it would be like if we had a whole bunch of these lights coming through. Right at this point, all of a sudden they would all split up, and you would get this, you know.
And that's why our very first cover slide, right, is showing just a white light entering this prism, breaking up into the rainbow.
Right.
And that's because of what Kip has just been talking about. These N values are different for each
I guess
wavelength of light.
So with that brings us to the next part.
Yeah.
Why is it round?
Why is it round?
So,
So you gave them the hint, right?
Yeah.
The sun. We got to think about what shape the sun is. It's a sphere.
Yeah.
For the most part.
Yeah.
It might not be a perfect sphere, but nothing is.
Go watch our video on derivatives if you want to learn how nothing's perfectly round.
Right. But the sun, when we look at it, it looks like a circle. And so why did you give that hint? Okay.
Well, Jaden, if we think about it, each one of those light rays coming off the sun, right? Oh, I guess we didn't actually answer why. I mean, the light is refracted through all the water droplets. So that's what causes the refraction. That's an important little part there. And that's why it only happens, when there's water. Because now there's a different medium in the air, right? And now those sun rays are hitting it. But the sun is round, right? So if you picture a whole bunch of little sun rays coming off around the sun, each one of those rays is going to hit some water and it's going to refract to its color spectrum. Right? And since the sun is round, it's going to do that all the way around. And we can't see it from Earth, but in certain circumstances, you can actually see that you can see a turtle circle rainbow. A turtle circle. But a total circular rainbow. And that's because it's literally like a refracted projection almost of the sun. And so that
is really cool.
That is really cool.
So if you think that rainbows are arches, you're wrong. They're actually circles.
Yeah. And
from the sun, anyways.
On top of that, that's why you also can't ever get to a rainbow, is because it's as you move closer to it, right? Like where your eyes are perceiving it moves away because of the refraction. Anyways, it's not actually an actual object. It's just light being refracted.
So technically, every rainbow is different.
Yeah.
Even if we're looking at the same rainbow, it's going to be different because we're at different positions. We're going to see the light refracting through droplets differently.
And we'll probably talk about that next class when we talk about lenses a little more. Because, spoiler, our eyes are a type of lens. Oh gosh. Okay, so that leads us to this, right? Snail's law for different wavelengths, which we've kind of already covered at this point, which is different wavelengths affect the medium differently, and so they have different n values. And then the last part that we haven't covered yet is if we remember back to that equation where it was C equals the frequency times the wavelength.
Right.
But now we're in a different medium, so it's no longer C, it's V. And when you divide V by F, you get a new wavelength. So the wavelength, you divide the velocity by the wavelength and you get a new frequency. So the wavelength always will stay the same, but the frequency changes.
So that's
where
kind
do
of
leprechauns keep their gold? I don't know.
Maybe at the center of the rainbow.
Maybe.
Ooh. We've been looking wrong this whole time.
So yeah, that's kind of
What am I looking at? You're looking at Snell's law for different wavelengths.
Yeah, you are. Which leads us to our last challenge question.
Dun dun dun.
So, what color bends the most?
I think we might have said this throughout today, but if you've been listening, good job, and you'll get the answer right. If you haven't, shame on you. Yeah. But you can still guess an answer.
Also, spoiler, it might be in the picture.
Oh, yeah. Ooh.
So.
That cool double rainbow.
Dude, double rainbow all the way across the sky.
Yeah, well, like Kip was saying, the frequency changes. So that is the reason why we get this split light, right? That's why the different colors bend differently, right? The frequency changes differently for each color.
Yeah,
And that's really cool to think about.
that's really cool. Okay,
We
so
got a B.
We
We got a red.
Okay.
So we got a A and a B. Okay. Ooh, spooky. Any others?
I don't know. Tonight's not a popular night. I thought it'd be the most popular night because no jazz game, dude.
Right.
But I didn't do a great job of publicizing this week.
That's alright. Silly jazz.
Dude, silly jazz.
It's like they're winning this year.
No. Okay, so we got red and blue. And back, we'll give you a few more seconds to answer, but
Wait!
So back to what we were talking.
What are we waiting for?
I don't know. It
B.
better be big. Oh, okay.
Did we get 2 Bs?
We got 2 Bs.
Oh,
B.
3 Bs.
3 Bs.
Yeah, it just came in.
Nice.
And also jazz bad.
Okay. So with this, right, we go back to that question about the sun and golden hour and all these kind of things. And again, it's because that red light bends less. And so if here's, the horizon and the sun comes down here, the red's the only thing that's going to pass over. The blue
is going down.
It's going down
to the daytimers, not the night timers.
Exactly. Oh, we got another B. Nice.
Whoa.
So
Shaylee popped in.
Yeah, Shaylee did pop in. So now that we have all this, we can roll, dude. And
so we got 4 Bs.
And we can get our... Oh, we got another... What was it? Oh, yeah. So we can now roll. Okay. And
that was an easy question, so we're taking the max.
Yeah, but no, they all got it right.
So we just take the max.
Yeah, we get health back, dude.
That's amazing.
Dude, what do we get?
We might end up with a 19.
19. So we're back up to 100 health. Good job, guys.
You are saving us. Woohoo! Shaylee popping in at the last second.
Well, there you guys have it. Light now has learned refraction. Now, here's your thought-provoking question to get you guys ready for next week. So far, we've talked about a medium that is flat, right? If we go to the picture, wherever it is here, we've been talking about how this is a straight line, right? But Jaden, on a lens of a camera, it's round.
Uh-oh.
So what happens when it's no longer a flat straight line, but when it's rounded?
Well, I don't want to give away any answers, so they're going to have to come back next week
to learn. But that's what we'll be going over. And so just think about that. Think what would happen to this light as it turns round, or as the surface becomes more rounded. And that might help you understand why a lens is round and it's not just a flat piece of glass.
And also, you probably never thought about it, but your eyeball is a lens.
And it's round too.
Ooh.
So that's pretty neato. Sweet. Well, thank you all for watching. Don't forget to hit like if you haven't.
Subscribe and donate because we're cool and you get a sticker or a name color change. Yeah. Or don't donate, but it's okay.
We'll just be mad at you.
Yeah.
Well, thanks for watching.
Yeah. Thank you. See you next time.